Generic functions and methods are another powerful feature of the Swift language. A generic function or method can work with any type. Thus, we can avoid duplications and write cleaner code. Let's start with a programming challenge. We need to implement a method which tells whether two values are equal. First, we define the isEqual function for strings. Pretty straightforward. Then, we need the same feature for double types. Not a big deal. What about dates? Luckily, that won't take too long to implement either. Then, we also need to tell whether two data instances are equal. Done. By now, you probably see where this goes. And if you watched the lesson about type explosion, you know what I'm about to say. This is not the way to go. Implementing a new function for every new type leads to a lot of redundant code. Such a codebase is hard to maintain and use. We should always avoid code repetitions, and generics help us solve this problem too. Alright, let's create the generic isEqual function. The syntax for writing a generic function is similar to what we use to declare generic types. We specify the placeholder type between angle brackets after the function or method name. We can refer to this placeholder type in the argument list or anywhere in the function's body. If we compile our code as it is now, we get an error. This is because the compiler doesn't know how to compare two instances of the placeholder type. We must ensure that the type implements the equal to operator. Types that adopt the equatable protocol must implement the equal to operator. So, we must enforce a type constraint. Type constraints specify that a type must conform to a particular protocol or inherit from a specific class. Let's add the equatable type constraint. This limits the types that can be used as arguments in our function. We got rid of the compiler error. Now, the generic isEqual function can only accept instances of types that adopt the equatable protocol. Contact is a struct that doesn't conform to the equatable protocol. Our code won't compile if we try to use the isEqual function with two contact instances. So, let's add the equatable protocol conformance. To adopt the equatable protocol, we have to implement the equal to operator as a static member. The implementation is simple. We check whether the properties of the two arguments match. The equatable protocol also defines the not equal operator. We don't need to implement it though. The standard library provides a default implementation. This calls the custom equal to operator and negates the result. We can apply type constraints also to generic types. You may remember the generic pair struct that we implemented in the previous lesson. Let's say that we want to limit the types to those that implement the comparable protocol. Here's what we should write. With this type constraint, we can only create pair instances out of types that adopt the comparable protocol. Generics are super useful. And Swift makes it easy for us to implement and use generic types and functions. In the following lessons, we're going to cover the built-in Swift collection types.